Scientific notation. Scientific notation is to help make huge numbers easier to read, add, multiply, divide, put together, or really small numbers easier to put together, add, multiply, or divide. And a good example is if we was to determine the mileage from the Earth to the Sun. I mean, those numbers would be so big, so scientific notation would be a perfect way to set up those numbers to work with. So, scientific notation in standard form. We have A times 10 to N, where A is a number that is 1, it could be 1, or greater than 1, and A is all positive numbers, so that's why it's in the absolute value bar. Or it could be less than 10, but not equal to 10. So A can be 1 through 9. It could be equal to 1, it could be equal to 9, but it's not going to be equal to 10, and it's not going to be bigger than 10, it's not going to be less than 1. Where N is going to be the power, the degree on my 10, because we're working in tens. So if it's positive number, it's going to be a large number, a large outcome. If N is equal to a negative number, well, then it is a small outcome. So, for example, say that I have 2.4 times 10 to the 22nd. Well, that's going to be a really big number, and we're going to move the decimal place if we're going to write it in, okay, so this is in scientific notations, and if we wanted to convert it to standard notations, then we would have to grab this decimal right here, and move it in this direction because this is positive. Okay, so since it's a positive number, we're going to move it 22 places. So I have 2.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2. And we're just putting our zeros right here. So this is a really big number. So you can kind of see why scientific notation is really helpful with really big numbers. It's easier to write it that way. So what if I had 2.4 times 10 to the negative 7? Well, then we're going to take this decimal right here, and we're going to have to move it in this direction because this is negative. So this is in scientific notation. Scientific notation, we're writing it in standard notation. Scientific. Notation, and this is standard. This is what we're used to seeing. And this is, there we go. So let's do this. So let's take this 2, 4, and let's grab it and go 1, 2, 3, 4, 5, 6, 7. And my decimal would go there. And we have it written in standard form. So if I was to want to undo it, so say that it's already in decimal form and I want to write it in scientific form, let's say that we have, what, 0. Okay, so this is standard form, right? And so now let's write it into scientific form. If I was to write it in scientific form, I have to determine where is that decimal going to go. Remember, A, the number in front of the decimal, can equal 1 or it can be any number between 1 and 10, but it can't equal 10. It can equal 9, but not 10. So what I see here is that I have the 7, and I'm going to put that decimal right there. And I got to count how many places I had to move it to get it there. So I'm going to go 1, 2, 3, 4, 5. So that means my 10 is going to be raised to -5 because it's a small number. And it took 5 places to move that decimal where it belongs. And my number is 7.91. And that's scientific notation.